स्टूडेंट्स यहाँ पे क्वेश्चन गिवन है, स्पेसशिप ऑर्बिट्स अराउंड अ प्लैनेट एट अ हाइट ऑफ 20 किलोमीटर from its surface, assuming that only gravitational field of the planet acts on the spaceship. What will be the number of complete revolutions made by the spaceship in 24 hours? ठीक है, अराउंड द प्लैनेट। अब यहाँ पे क्या गिवन है, हमारा मास ऑफ प्लैनेट गिवन है यहाँ पे, और रेडियस ऑफ प्लैनेट गिवन है, ग्रेविटेशनल कांस्टेंट गिवन है। तो सबसे पहले देखते हैं, जो स्पेसशिप होगी वो सर्कुलर पाथ में घूम रही होगी ड्यू टू, जो स्पेसशिप को सर्कुलर पाथ में घूम रही है ड्यू टू सेंट्रीपिटल फोर्स, ठीक है, जिसके कारण उस पर mv²/r, ठीक है, एक ऑर्बिटल वेलोसिटी होगी। तो इन दोनों के बीच जो फोर्स लग रहा है, इट इज ड्यू टू द अट्रैक्टिव फोर्स बिटवीन स्पेसशिप एंड द अर्थ, ठीक है। इसकी वैल्यू होगी हमारी g इंटू मास ऑफ अर्थ इंटू मास ऑफ स्पेटलाइट बाय r², ठीक है, यहाँ पे mv², सही है। तो देखिए यहाँ से हमारी v की वैल्यू आ गई, यहाँ से हमारी v की वैल्यू आ गई √g मास ऑफ अर्थ बाय r रेडियस, सही है। तो हम ऐसे टाइम पीरियड निकालेंगे। टाइम पीरियड हमारा क्या होता है, टाइम पीरियड होता है हमारा 2πr/, अगर हम यहाँ पे v की वैल्यू पुट कर दें तो हमारे पास आ जाएगा 2πr, v का वैल्यू कितना है यहाँ पे, √r/gm, जिसे लिख सकते हैं हम लोग 2πr3, हमने r को अंदर भेज दिया, बाय g इंटू कैपिटल मास ऑफ अर्थ, ठीक है, मास ऑफ अर्थ होगा। टाइम जैसे टाइम पीरियड आएगा हमारा, तो ऐसे वैल्यू आएगी 202³ इंटू 10⁻12 बाई 6.67 इंटू 10⁻11 इंटू 8 इंटू 10⁻22, ये होगा हमारा सेकेंड्स में, ठीक है। तो यहाँ से हमारी वैल्यू आ गई, टाइम पीरियड इज इक्वल्स टू 7812.2 सेकेंड्स, ठीक है। तो अगर इसे आवर्स में हम लोग कन्वर्ट कर लें, ठीक है, अगर इसे आवर्स में कन्वर्ट कर दें तो वो हो जाएगा हमारा टाइम इक्वल्स टू 2.17 आवर, ठीक है। तो हमें बताना है नंबर ऑफ रेवोल्यूशंस, ठीक है। तो नंबर ऑफ रेवोल्यूशन क्या हो जाएगा हमारा, n इंटू 2.17 इज इक्वल्स टू 24 आवर होगा हमारा। तो जब इसे डिवाइड करें तो n की वैल्यू अप्रॉक्सीमेट हमारे पास आ जाएगी 11, ठीक है। तो यहाँ पे आंसर जो हमारा रिक्वायर्ड है वो है 11। थैंक यू।
Hello everyone. A rocket has to be launched from the earth in such a way that it never returns. If E is the minimum energy delivered by the rocket launcher, what should be the minimum energy that the launcher should have if the same rocket has launched from the surface of the moon? Assume that the density of the earth and moon are equal and that Earth's volume is 64 times the volume of the moon. Okay, so let us first understand what is the minimum energy delivered by the rocket launcher so that it never returns to the earth again, right? So let us draw. Let's suppose this is the earth and we want any object launched from this surface never return to its surface, right? So let's suppose the radius of the earth is RE and we are launching here with some kinetic energy K initial, right? So if we want this rocket to never return to this surface of the earth or in the field of the earth, then what will happen at the infinity, it will reach, right? So from the mechanical energy conservation I will write U initial plus K initial should be equals to U final plus K final. So when the R will approaches to infinity, U final will approaches to infinity, and when this will happen, the rocket will never return to the surface of the earth. Never return. Simple. Okay. So when this will happen, now we want the minimum energy. So I will make this K final also 0. So from here you will get the minimum energy, that is kinetic energy required from the surface of the earth is this, which is equals to negative of G mass of Earth by radius of Earth. You can see initially they are at a distance of RE, right? And let's suppose the mass of the rocket is small m, right? So this will be the energy required for launching the rocket so that it never returns to the surface of Earth. So I will write it as E. Now it is given in the question that the both have same density, right? But volume of Earth is more, 64 times of the volume of the moon, right? So let's suppose I write here volume of the Earth is equals to 64 times of volume of the moon, right? So I will write 4 pi by 3 radius of Earth whole cube, 64 times of 4 pi by 3 radius of moon cube. Okay, so this 4 pi by 3 will get cancelled out and you will get RE is equals to RE cube is equals to 64 this, right? Now you could find the relation between the radius of Earth and the radius of moon. So I will write radius of Earth is 4 times of radius of moon. Very simple. Now if you see, the energy required is inversely proportional to the radius, right? Now let's talk about the mass, right? So it is given that both are of same density, right? So if I talk about the masses, like mass of moon by mass of Earth, right? So it will be density into volume of moon, density into volume of Earth. Simple. Now we know that density of moon by density of Earth is 1, since both are having same density. And if I talk about the volume, you could see from here that the volume of moon by volume of Earth is 1 by 64, right? So it is 1 by 64. The moon is having 1 by 64 times of volume of the Earth, right? So we got the ratio of mass and ratio of the radii, right? And if you see in the question, we wanted the energy that should be given from the surface of the moon, right? So let's suppose that energy is E dash, right? So let's suppose I take E dash is the energy from moon surface to be projected, right? Okay, and we know that this energy is G mass of Earth by radius of Earth by this. So I will write E dash is equals to G mass of moon by radius of moon into mass of rocket. Now you can divide the two. I will write E dash by E is equals to, I will write G mass of Earth into mass of the rocket by radius of the moon into G mass of Earth, mass of the rocket divided by radius of the Earth. This G will get cancelled out, M will also get cancelled out. So you will get mass of moon by mass of Earth into radius of Earth by radius of moon. Right, now you can just put the value. We already calculated the mass of moon by mass of Earth is 1 by 64. And if I talk about the radius of Earth by radius of moon, that is 4. So you can just put the value here. The radius ratio is 4 here. And this mass is 1 by 64. If you see, we already calculated this. And so this will be the ratio of energy. Now we know that already the E dash is equals to E by 16. So energy with which the rocket should be projected from the Earth's surface is 1 by 16 times of the energy with which the object should be projected from the Earth's surface, right? So moon, from the moon surface, it should be projected with this much energy, E by 16. Now you could see the question again. This was our question, and we got E by 16 as the energy that the rocket should have at the surface of moon, so that it never returns to the surface of the moon. Thank you.
Hello students, today our question is a rocket is launched normal to the surface of earth away from the sun along the line joining the sun and earth. The sun is 3 into 10 power 5 times heavier than the earth, is at distance of 2.5 into 10 power 4 times larger than the radius of UE is 11.2 km per second. The minimum initial velocity is UE and this is 11.2 km per second, and the minimum initial velocity US required to rocket to be able to leave the sun system is closest to ignore the, we have to ignore the rotation of earth and the presence of any other planet. So we have A, B, C, D option is given here. So we have to find the minimum initial velocity US here. And so the solution of this question is, we have mass is given to us. Mass of the sun is 3.5 meter heavier than earth. Mass of sun is 3 into 10 power 5 heavier. So we can write this is times of earth, and D is equals to 2.5 into 10 power 4 radius of earth here, and we have velocity VE, velocity of earth is 11.2 km per second here, and this will equals to under root G 2 time of G, and this is mass of earth and this is divided by radius of earth. Now the sun earth system is sun system is equals to, this is half mv square, that is this is of earth velocity here, this is our velocity of sun here, and in its subtraction to we have to minus here, subtract mass of earth into m, and this is divided by radius of earth, and this is gm mass of sun, and this is multiplied by earth, and this is radius of sun, and this is radius of sun is radius of earth plus d. So we can write here this is radius of earth plus d, and this is equals to 0. So assuming that radius of earth is so small than d, so taking the value of gm e divided by r is 11.2 square, and this is divided by 2. So we get velocity of sun is equals to 42 km per second, and this is velocity is approximately equals to it. So this is our answer here. Now we check which option is correct here. So our option B will be correct here. Thank you.
Hello students, let's understand the given question. A satellite is revolving in a circular orbit at a height of h from the Earth's surface, radius of the Earth capital R. The minimum increase in its orbital velocity required so that satellite could escape from the Earth's gravitational field is close to. Neglect the effect of atmosphere. So question is saying that one of the satellite, this is revolving in a circular orbit at a height of h from the surface of the earth, and radius of the earth is equal to capital R. So we have to calculate the minimum increase in its orbital velocity to escape the satellite from that place or from that orbital path, and we have to neglect the effect of atmosphere. So we have four options. First, root of 2gr, second, root of gr, third, root of gr upon 2, fourth, root of gr into root 2 minus 1. So we have to tell that which of the following option is correct. Now we can start from the given. So here we have given height, this is equal to h, radius of earth, or we can write here re, radius of earth, that is re, is equal to capital R we have given. So we have to calculate the increase in orbital velocity to escape the satellite, del V naught, we have to calculate. So suppose this is the orbital path of the satellite, and here is the earth. Mass of the earth is capital M, and radius from the surface of the earth to this satellite, this is equal to, we have h. So we can say that if this satellite is revolving in the circular path, so here will be the centrifugal force, and this centrifugal force is balancing with the gravitational force of the earth. So we can write here that G capital M into small m. Small m is the mass of the satellite. So G capital M into small m upon center of the earth to the satellite distance, that is capital R plus h square of that should be equal to centrifugal force, because this is orbiting in a circular path, so force should be balanced. So this will be Gm upon, this will be equal to mv square upon r. This centrifugal force is mv square upon r. V naught we are taking orbital velocity, so V naught square upon capital R plus small h. So here we can write here G small G, this will be capital M, G capital M upon R plus small h will be equal to V naught square. So we can write here that V naught will be equal to root of Gm upon R plus h. So this is equation first, or we can say this is orbital velocity. Now what we have to do, if this satellite is escaping, means this is leaving this or this circular path, so the required velocity here that we have to calculate. So we know that for escaping, that total energy at this point, that is kinetic energy plus potential energy, should be equal to 0 at a escaping velocity. So we can write here that potential energy of this satellite at this point when it will escape, this velocity is VE. So G into small m upon capital M upon distance capital R plus a small h minus of that, because we know that potential energy is always negative, plus kinetic energy half of m into VE square, that should be equal to 0. So we can write here that VE square is equal to 2 G capital M upon R plus h root of that, or we can say this is equal to VE. Okay, so we have value of VE and we have value of V naught. So to to escape this satellite, increase velocity should be V naught, VE minus V naught. So we can write here del V naught is equal to VE minus V naught, and this will be equal to root of Gm capital M upon R plus h minus Gm R plus h. Now Gm upon R plus h square is equal to gravitational acceleration at that point. So we can write here G is equal to gravitational acceleration at this point will be equal to G mass of the earth upon R plus h square. So we can write here that Gm upon R plus h, we can write 2G, and we have to multiply by R plus h. So root of 2G R plus h minus of here, this will be root of 2G, this is only root of that G R plus h. So G into R plus H. Now if H value is very less than R value, then we can directly write root of 2G capital R minus root of GR. So we can write here again, we can take root of GR common, root of GR we can take common, so this will be root 2 minus 1. This is equal to increase in orbital velocity to escape that satellite. So we can write in the final answer that increase in orbital velocity of satellite is equal to root of GR into root of 2 minus 1. Now we have to see the options. Root of GR into root 2 minus 1 should be the answer. That is option. That is last option, option D we can say. So root of GR into root 2 minus 1 is the correct answer for this question. I hope you understood the solution. Thank you.
The question is a spherically symmetric gravitational system particle has mass density. This rho is given here, R is less than and R is greater than. So where P naught is constant, a test mass can undergo circular motion under the influence of gravitational field. So particle its speed v as function of distance r. Here this value 0 to infinity from the center of system is represented by. Now here we can check for this value. Firstly we consider r is for here r is less than is equal to here r. Now here we can write because this is a move on circular motion and the centripetal force provided by gravitational force. So we can write mv square by r here is equal to gmm by here r square. Now we can put the value of m is equal to 4 by 3 pi r cube. Now here this we can substitute this value of in this equation. So we can write mv square by r is equal to gm and here 4 by 3 pi r cube p naught by here this is the r square. So here when we can calculate this term, so here this is m to m cancel and here r is cancel. So here we calculate after, so it will come v inversely. V is proportional to r. Here first case we will get V proportional to r. Now here for this second case r is greater than r. So here in that case we can write equation directly, write v square by r is equal to g 4 by 3 pi r cube p naught by r square. So now here because here we can write because m to m cancel. Now here we directly write here. So in that case v is inversely proportional to 1 by under root r. Now here we can check the option which one is right. So here the first case is here v is proportional to r. In that case we get a straight line. Now here we can see is the first option. Now here the option is the not match this graph. So here we can draw like this graph will come like this. This is a here this is a v and here this a r. So here v proportional to r. So we will get a straight line like this. This is a straight line for this v proportional to r. Here we can write this is a v proportional to r. Now here we get this term like we will get now here v is inversely proportional. So here we get this graph. So now here this is the r. So this is the solution of this question guys. Thank you.
हेलो स्टूडेंट, इस क्वेश्चन में दिया हुआ है कि अगर मान लेते हैं जी जो एक्सेलरेशन ड्यू टू ग्रेविटी है, ठीक है ना, अर्थ सरफेस का, और उसका गेन कितना होगा, पोटेंशियल एनर्जी में गेन कितना होगा अगर मास एम का ऑब्जेक्ट है उसको जो है ना हम लोग क्या कर रहे हैं हाइट एस से अर्थ के सरफेस से थोड़ा दूर ले जा रहे हैं आर डिस्टेंस, ठीक है, जहाँ की आर जो है ना रेडियस ऑफ अर्थ है। तो चलिए हम फाइंड करते हैं, पहले निकालते हैं कि इसका इनिशियल पोटेंशियल एनर्जी क्या होगा। तो यू इनिशियल क्या हो जाएगा, अगर मान लेते हैं कि कोई भी ऑब्जेक्ट अर्थ पे, तो क्या हो जाएगा माइनस जी एम अपॉन आर हो जाएगा। अब u फाइनल कितना हो जाएगा उसी ऑब्जेक्ट का, अगर मान लेते हैं कि r डिस्टेंस लेके चल जाते हैं, अब r प्लस r 2r हो गया डिस्टेंस, तो माइनस g m अपॉन 2r हो जाएगा। ठीक है, तो हम चेंज कितना आ गया पोटेंशियल, u फाइनल माइनस u इनिशियल कितना हो गया यहाँ पे, माइनस g m अपॉन 2r माइनस 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 ऑफ हो जाएगा g m अपॉन r हो जाएगा। ठीक है, अगर इसको हम आगे सॉल्व करें तो हमारे पास आ जाता है डेल्टा u का वैल्यू जो आ जाता है कि यहाँ पे जो है ना 2r जो है ये निकल जाएगा, कॉमन निकल जाएगा और ये माइनस माइनस प्लस हो जाएगा। ठीक है, सो ये 2r तो हम निकाल लिए यहाँ पे, ये एलसीएम ले लिए, तो माइनस जी एम प्लस 2gm इंटू एम हो जाएगा। ठीक है, तो यहाँ से डेल्टा यू का हमारे पास वैल्यू आ गया gm इंटू एम अपॉन 2r हो जाएगा। ठीक है, gmm डेल्टा यू इज इक्वल टू हो जाएगा gmm अपॉन 2r हो जाएगा। ठीक है, और हमें पता है कि g का वैल्यू कितना है, g का वैल्यू है gm अपॉन r स्क्वायर है। ठीक है, और यहाँ पे हमारे पास gm का वैल्यू जो आता है gr स्क्वायर आ जाता है, सो gm की जगह क्या करते हैं हम लोग पुट कर देते हैं gr स्क्वायर। ठीक है, सो डेल्टा u का वैल्यू आता है gm की जगह अगर हम gr स्क्वायर पुट करें, स्मॉल gr स्क्वायर अपॉन 2r, r से r कैंसिल हो जाएगा, तो gmr अपॉन 2 आंसर हो जाएगा, जो कि ए नंबर ऑप्शन में अगर हम यहाँ देखें तो ए नंबर ऑप्शन में दिया हुआ है, सो हमारा करेक्ट आंसर ए है।
Hello everyone. In this problem, it is given that two spherical planet PQ have same uniform density, masses MP and MQ, and the surface area is given here A and 4A respectively. A spherical planet R also has uniform density rho, and its mass is mass of planet plus mass of Q, planet Q and planet P. The escape velocities from the planet PQ are given, that is BP, VQ and VR respectively. Then we have to find out the corresponding relationship between the escape velocity. So let's solve here this problem. So first of all, we know that escape velocity for any planet, that is root 2g mass of that planet upon radius of that planet. So in problem we have given here that area of planet P is given A and area of planet Q is given 4A. So if I take ratio of their area, I will get the relationship between their radius. So here I will have A upon 4A. This will be 4 pi radius of planet P square upon radius of planet Q square. So in this way I will get here radius of planet P upon radius of planet Q. This will be 1 by 2. So in this way I will get the first equation here, that RQ is nothing but it is twice of RP. This is my first equation. Now secondly I have to find out their mass relationship. So here mass of planet P upon mass of planet Q, this can be written as rho into volume 4 by 3 pi radius of planet P whole cube upon rho into 4 by 3 pi radius of planet Q whole cube. So in this way if I solve this, I will have mass of planet P upon mass of planet Q, that can be written as here Rp upon Rq is given here 1 by 2. So whole cube of 1 by 2, this will comes out 1 by 8. So mass of planet P upon mass of planet Q will be comes out 1 by 8 here. So from here I can write that mass of planet Q can be written as mass of planet P. This is my equation first. If I further solve this problem, here given that radius of mass of third planet, which is R, is given mass of planet P plus mass of planet Q. So in this way if I put here mass of planet Q, which is here 8 MP, so it will comes out 9 mass of planet P. So mass of planet R has been related here with mass of planet P. So if I try to find out their radius relationship, so I can write this expression further. This is equation number, I will have this is equation number 2. Now in this way if I solve further, here I can write here rho into 4 by 3 pi. This is the radius of third planet, which is r cube. This can be written as rho into 4 by 3, and this will be pi rp whole cube. So in this way I can relate their radius here, radius of third planet. This can be written as 9 to the power 1 by 3 r of p. So this is my equation third. So now this all what I need here. Now I'm taking their relationship here. Iske velocity is clearly it is proportional to mass of certain planet, mass of any planet, and radius of that planet. So in this way, if I take ratio like this way, p, q and third r. Now after putting all this value, I will get mass of planet p, radius of planet p upon mass of planet q upon radius of planet q, ratio mass of planet r upon radius of planet r. So I have to just put here all the corresponding value here. This will be mass of planet p upon rp, ratio mass of planet q, it is 8 times of mass of planet p, and its radius is also 2 times of radius of planet p, and here mass of planet r, it is 9 times of mass of planet p, and radius r, it is 9 to the power 1 by 3 radius of planet p. So in this way, if I find the relation between the escape velocity, so escape velocity q will be greater than r will be greater than r vp. So if I look at the option, our option number first will be correct answer of this given problem. Thank you.
Hello everyone. The masses and the radii of Earth and Moon are given. Their center are at a distance of d apart. Minimum velocity with which a particle of mass m should be projected from midpoint between the two centers so that it escape to infinity. So if you see, if I apply the mechanical energy conservation, since there is no other force other than the gravitational attraction, right, so we can apply the mechanical energy conservation on the particle. So I will write the final mechanical energy is equals to initial mechanical energy, that is this. So let's say we want, if you see, we want the minimum speed. So let's say we gave the minimum speed to the particle v naught. Right, I am saying this much, if I gave this much velocity, it will at least leave to the infinity, at least leave to the infinity. Now if I write down the initial potential energy, so it is projected from the midpoint, right? So if I write down the initial potential energy, so I will write G mass of, if you see, mass of Earth is masses of Earth and Moon are given. In division, the distance is d by 2. It is also from the moon, also it is at the same distance. So this will be the initial potential energy. So I will write 2g by d m1 plus m2 with a negative sign as the potential energy. Just put it here. Now if you see this minimum again, right? So we want the minimum velocity. So to minimum velocity, at infinity it will be having 0 velocity, and at infinity the potential energy is 0. So finally I will write half m v naught square is equals to 2g m1 plus m2 by d, right? Now I will write the v naught is equals to under root of this into 2, that is 4 m1 plus m2 by d. And this is the answer of this question. Thank you.
Hey everyone, I'm going to explain this question, and the question is: a bullet is fired vertically upwards with a velocity v from the surface of a spherical planet When it reaches its maximum height, its acceleration due to gravity, due to the planet's gravity, is 1/4 of its value at the surface of the planet. If the escape velocity from the planet is v escape is v root n, then the value of n is ignored loss due to atmosphere. So we are going, there is no atmosphere, we are going to assume it. So basically question is, there is a planet, spherical planet, let's say this is our planet, alright. So a particle is thrown here, a bullet is thrown here with a velocity v, right? It reaches a maximum height, let's say, and here let's say here acceleration due to gravity was g, right? And here it becomes g upon 4, right? Here v is equal to 0, and let's say this height is h, all right. So it's asking its velocity of escape. Okay, so we are going, what we are going to do is we are going to first find the height. We know that acceleration due to gravity, right? For any satellite or any particle, let's say particle has a mass m, you know that ma, that is force, is equal to g mass of m. Here mass m is mass of planet, m upon r square, right? So here r is the total distance, right? So I have some assumptions. So the assumptions are m is equal to mass of planet, capital R is radius of planet, right? And m is mass of particle, right? So initially value of g is g, let's say. So we know that mg is equal to g m upon r square, right? So from here we are getting value of g is equal to gm upon r square, right? At height h, right? At height h, m g upon 4, right? That will be equal to g m upon r plus h whole square, right? This will be the value. Now if we put the value, we will get g mgm upon 4r square is equal to g m upon r plus h whole square, right? Solving this, we will get h is equal to r, right? 4r square is equal to r plus h square, which implies h is equal to r, right? This is value of h is equal to r. Now what we are going to do, once we know the value of h, we can apply energy conservation. Let's say this is point A and this is point B, right? We can apply energy conservation to find the value of v, right? Now applying energy conservation, right? At A, potential energy is minus gm upon r, right? We have at A potential energy minus gm upon r plus half m v square is equal to, this is potential energy at A, and at B potential energy will be minus gm m upon r plus h, that is 2r, plus kinetic energy is 0, right? This is the kinetic energy, because at maximum height there is no velocity, right? Solving this, we will get value of half mv square is equal to gm m upon r minus gm m upon 2r, which is gm m upon 2r, right? So from here we are getting value v is equal to, right, v is equal to gm upon r root, right? The 2 will get cancelled, get cancelled, overall we will be gm upon r. Now for any satellite or any particle velocity of escape, VE is equal to simply 2gm upon r whole root, right? We can easily prove this. We know that for velocity of escape, total energy should be 0, right? Because at infinity there is no energy, right? So which can be proved easily, like how total energy is equal to 0, which implies gm m upon r, that is multiplied by -1, which is potential energy, plus half m VE square. Kinetic energy should be 0 at surface, which gives us V escape is equal to 2gm m upon r, right? So this is the velocity. So from here we can easily say that velocity of escape is V root 2, right? See, this is V and this is velocity of escape. If we multiply V with velocity, root 2, we will get velocity of escape. So our answer will be value of n is equal to 2, right? This will be our answer. Okay. So our answer will be option A. Alright, this was the explanation. Hope you understood it. Bye bye.
Hello everyone. Question is, there is a crater of depth r by 100 on the surface of moon. A projectile is fired vertically upward from the crater with the velocity which is equals to escape velocity from the surface of moon, जो कि escape velocity equal है. Find the maximum height attained by the projectile. ਆਪਾਂ ਜਿਹੜੀ ਹੈਗੀ ਹੈ ਮੈਕਸਿਮਮ ਹਾਈਟ ਕੀ ਕਰਨੀ ਹੈ ਅਟੇਨ ਬਾਈ ਦਾ ਪ੍ਰੋਜੈਕਟਾਈਲ ਦਿੱਤੀ ਹੋਈ ਹੈ, ਠੀਕ ਹੈ. ਉਹ ਹਾਈਟ ਕੀ ਕਰਨੀ ਹੈ ਆਪਾਂ ਫਾਈਂਡ ਕਰਨੀ ਹੈ. ਆਪਾਂ ਨੂੰ ਕ੍ਰੇਟਰ ਦਿੱਤਾ ਹੋਇਆ ਤਾਂ ਆਪਾਂ ਇਹਦਾ ਦੇਖੋ ਸੋਲੂਸ਼ਨ ਕੀ ਕਰਦੇ ਆਪਾਂ ਇਹਦਾ ਸੋਲਵ ਕਰਦੇ ਹਾਂ. ਸੋਲੂਸ਼ਨ ਜਦੋਂ ਆਪਾਂ ਇਹਦਾ ਕਰਾਂਗੇ ਤਾਂ ਇਹਦੇ ਚ ਦੇਖੋ ਆਪਣੇ ਕੋਲ ਆਹ ਅਰਥ ਮੰਨਿਆ, ਆਪਣੇ ਕੋਲ ਮੂਨ ਦੀ ਸਰਫੇਸ ਦਿੱਤੀ ਹੋਈ ਹੈ. ਆਹ ਆਪਾਂ ਮੂਨ ਦੀ ਸਰਫੇਸ ਦਾ ਕੀ ਮੰਨਿਆ, ਸੈਂਟਰ ਮੰਨਿਆ. ਮੂਨ ਦੀ ਸਰਫੇਸ ਦਾ ਜਦੋਂ ਆਪਾਂ ਸੈਂਟਰ ਹੈ ਤਾਂ ਇੱਥੋਂ ਕੁਛ ਡੈਪਥ ਕਿਹਾ ਹੋਇਆ ਇਹਨਾਂ ਨੇ r/100 ਡੈਪਥ ਕਿਹਾ ਹੋਇਆ. ਕਿੰਨੀ ਡੈਪਥ ਕਿਹਾ ਹੋਇਆ ਆਪਾਂ ਨੂੰ, r/100 ਡੈਪਥ ਕਿਹਾ ਹੋਇਆ ਹੈ. ਇਹਨਾਂ ਨੇ ਕਿਹਾ ਕਿ ਇਸ ਡੈਪਥ ਤੋਂ ਆਪਾਂ ਇੱਕ ਪਾਰਟੀਕਲ ਨੂੰ ਵੀ ਕੀਤਾ, ਥਰੋ ਕੀਤਾ ਵਿਦ ਸਮ escape velocity ਕੀ ਕੀਤਾ ਆਪਾਂ ਥਰੋ ਕੀਤਾ, ਠੀਕ ਹੈ. ਪੂਰੀ ਕਿੰਨੀ ਸੀ r ਸੀ, ਤਾਂ ਜਿਹੜੀ ਆਪਣੇ ਕੋਲ ਬਚ ਗਈ ਉਹ ਕਿੰਨੀ ਬਚੀ r-r/100. ਤਾਂ ਆਹ ਵਾਲੀ ਜਿਹੜੀ ਆਪਣੇ ਕੋਲ ਬਚੀ ਕਿੰਨੀ ਬਚੀ 99r/100. ਕਿੰਨੀ ਬਚੀ ਆਪਣੇ ਕੋਲ 99r/100 ਕੀ ਆਪਣੇ ਕੋਲ ਬਚੀ. ਇੱਥੋਂ ਆਪਾਂ ਕੋਈ ਵੀ ਪ੍ਰੋਜੈਕਟਾਈਲ ਨੂੰ ਥਰੋ ਕੀਤਾ ਵਿਦ ਸਪੀਡ BE, ਹਾਈਐਸਟ ਪੁਆਇੰਟ ਤੇ ਗਿਆ ਤੇ ਜਿੱਥੇ ਜਾ ਕੇ ਉਹ ਰੈਸਟ ਉੱਤੇ ਆ ਜਾਂਦਾ, ਕਿਉਂਕਿ ਮੈਕਸਿਮਮ ਹਾਈਟ ਜਦੋਂ ਆਉਂਦੀ ਤਾਂ ਉਹ ਕਿਹਦੇ ਉੱਤੇ ਆ ਜਾਂਦਾ, ਰੈਸਟ ਉੱਤੇ ਆ ਜਾਂਦਾ ਹੈ. ਤੇ ਹਾਈਟ ਆਪਾਂ h ਕੀ ਕਰਨੀ ਹੈ ਜੀ, ਫਾਈਂਡ ਕਰਨੀ, ਠੀਕ ਹੈ. ਤਾਂ ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਇਹਨਾਂ ਨੇ ਕਿਹਾ ਕਿ ਆਪਾਂ ਥਰੋ ਕੀਤਾ ਵਿਦ ਐਸਕੇਪ ਸਪੀਡ. ਤਾਂ ਜਿਹੜੀ ਆਪਣੇ ਕੋਲ ਐਸਕੇਪ ਸਪੀਡ ਦਾ ਫਾਰਮੂਲਾ ਹੁੰਦਾ, ਉਹਦਾ ਫਾਰਮੂਲਾ ਹੁੰਦਾ VE is equals to under the root 2g capital M upon R, ਠੀਕ ਹੈ. ਤਾਂ ਅਗਰ ਆਪਾਂ ਇਹਨੂੰ ਸੋਲਵ ਕਰਨਾ, ਆਪਾਂ એનર્ਜੀ ਕੰਜ਼ਰਵੇਸ਼ਨ ਨਾਲ ਸੋਲਵ ਕਰਾਂਗੇ. ਆਪਾਂ ਕੀ ਲਿਖਾਂਗੇ, એનર્ਜੀ at depth D is equals to energy at highest point. highest point ਨੂੰ ਆਪਾਂ ਕੀ ਕਹਿੰਦੇ ਆ h. ਆਹ ਵਾਲੀ highest point ਹੈ ਤੇ ਆ ਕੇ ਮੰਨਦੇ ਆਪਾਂ depth D, ਠੀਕ ਹੈ. energy sum of two kinetic energy plus potential energy at D is equals to kinetic energy plus potential energy at h, ਠੀਕ ਹੈ. ਇਹਨਾਂ ਦੋਨੋਂ ਇਕੁਏਸ਼ਨਸ ਜਿਹੜੀਆਂ ਆਪਾਂ ਬਣ ਗਏ ਤਾਂ ਆਪਾਂ ਹੁਣ ਸੋਲਵ ਕਰਦੇ ਹਾਂ. ਹੁਣ ਇਹ 'ਚ ਦੇਖੋ ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਕਾਇਨੈਟਿਕ એનર્ਜੀ ਕਿੰਨੀ ਹੈ, ਹਾਫ m. ਐਸਕੇਪ ਵੈਲੋਸਿਟੀ ਨਾਲ ਥਰੋ ਕੀਤਾ, ਐਸਕੇਪ ਵੈਲੋਸਿਟੀ ਦੀ ਸਪੀਡ ਕਿੰਨੀ ਹੁੰਦੀ ਹੈ 2gm upon r ਦਾ ਹੋਲ ਸਕੁਅਰ. ਫਿਰ ਉਸ ਤੋਂ ਬਾਅਦ ਦਾ ਪੋਟੈਂਸ਼ੀਅਲ. ਤੁਸੀਂ ਹਮੇਸ਼ਾ ਇਹ ਚੀਜ਼ ਯਾਦ ਰੱਖਿਓ, ਜਦੋਂ ਵੀ ਆਪਾਂ ਨੂੰ ਸਫੀਅਰ ਦੀ ਪੋਟੈਂਸ਼ੀਅਲ ਦਾ ਫਾਰਮੂਲਾ ਆ ਜਾਂਦਾ, ਪੋਟੈਂਸ਼ੀਅਲ ਇਨਸਾਈਡ ਸਫੀਅਰ ਕਿਹਾ ਜਾਂਦਾ, ਠੀਕ ਹੈ. ਤਾਂ ਉਹਦਾ ਜੋ ਫਾਰਮੂਲਾ ਹੁੰਦਾ ਉਹ ਹੁੰਦਾ ਆਪਣੇ ਕੋਲ -g ਕੈਪੀਟਲ M ਸਮਾਲ m r ਕਿਊਬ ਉਰੇ ਕਿੰਨਾ ਹੁੰਦਾ 3/2 r ਸਕੁਅਰ -1/2 ਸਮਾਲ r ਸਕੁਅਰ. 3/2 ਕੈਪੀਟਲ R ਸਕੁਅਰ 1/2 ਸਮਾਲ r ਸਕੁਅਰ. ਹਮੇਸ਼ਾ ਯਾਦ ਰੱਖਿਓ ਸਫੀਅਰ ਦੇ ਅੰਦਰ ਪੋਟੈਂਸ਼ੀਅਲ ਦਾ ਫਾਰਮੂਲਾ ਹੁੰਦਾ. ਤਾਂ ਅਗਰ ਆਪਾਂ ਉਰੇ ਪੋਟੈਂਸ਼ੀਅਲ ਦਾ ਫਾਰਮੂਲਾ ਪੁੱਟ ਕਰਦੇ ਤਾਂ ਉਰੇ ਕਿੰਨਾ ਆ ਜਾਊ g ਕੈਪੀਟਲ M ਸਮਾਲ m r ਦੀ ਕਿਊਬ. ਫਰਦਰ ਅਗਰ ਆਪਾਂ ਇਹ ਫਾਰਮੂਲਾ ਪੁੱਟ ਕਰਦੇ ਹਾਂ ਉਰੇ ਕਿੰਨਾ ਆ ਜਾਊਗਾ 3/2 ਕੈਪੀਟਲ R ਸਕੁਅਰ -1/2. r ਜਿਹੜਾ ਉਹਦੇ ਸਮਾਲ r ਹੁੰਦਾ ਇਹ ਹੁੰਦਾ ਸੈਂਟਰ ਦੇ ਨਾਲੋਂ ਡਿਸਟੈਂਸ. ਕਿੰਨਾ ਦਿੱਤਾ ਹੋਇਆ ਆਪਣੇ ਕੋਲ 99r/100, 100 ਦਾ ਸਕੇਅਰ। ਫਿਰ ਇਹੀ ਜਿਹੜਾ ਫਾਰਮੂਲਾ ਇਹ ਆਪਾਂ ਡੈਪਥ, ਇਹ ਆ ਗਿਆ ਡੈਪਥ, ਫਿਰ ਉਹੀ ਫਾਰਮੂਲਾ ਆਪਾਂ ਹਾਈਟ ਤੇ ਲਾਉਣੇ ਆ। ਹਾਈਐਸਟ ਪੁਆਇੰਟ ਤੇ ਜਾ ਕੇ ਪਾਰਟੀਕਲ ਦੀ ਪੋਟੈਂਸ਼ੀਅਲ ਕਿੰਨੀ ਹੋ ਜਾਂਦੀ ਹੈ, ਕਾਈਨੈਟਿਕ ਕਿੰਨੀ ਹੋ ਜਾਂਦੀ ਹੈ, 0, ਉਹਨੂੰ ਆਪਾਂ 0 ਲਿਖ ਲਿਆ। ਤੇ ਪੋਟੈਂਸ਼ੀਅਲ ਦੀ ਜਿਹੜੀ ਵੈਲਿਊ ਕਿੰਨੀ ਹੁੰਦੀ ਹੈ, G ਕੈਪੀਟਲ M ਸਮਾਲ m R ਪਲਸ H। ਇਹ ਵਾਲਾ ਜਿਹੜਾ ਫਾਰਮੂਲਾ ਹੁੰਦਾ ਇਹ ਆਪਣੇ ਕੋਲ ਕਿਤੇ ਹੁੰਦਾ ਹੈ ਹਾਈਟ H ਤੇ ਹੁੰਦੀ ਹੈ, ਠੀਕ ਹੈ। ਫਰਦਰ ਜਦੋਂ ਆਪਾਂ ਇਹਨੂੰ ਸੋਲਵ ਕਰਦੇ ਹਾਂ, ਜਦੋਂ ਆਪਾਂ ਇਹਨੂੰ ਫਰਦਰ ਸੋਲਵ ਕਰਨ ਤਾਂ ਆਪਣੇ ਕੋਲ ਜਿਹੜੀ ਸੋਲਵ ਕਰਕੇ ਦੀ ਵੈਲਿਊ ਹੁੰਦੀ ਹੈ GMM, G ਕੈਪੀਟਲ M ਸਮਾਲ m ਨਾਲ ਸਾਰੀਆਂ ਟਰਮਸ ਕੀ ਹੋ ਜਾਣਗੀਆਂ ਕੈਂਸਲ। ਤਾਂ ਸੋਲਵ ਕਰਕੇ 1/r ਬਚੂ -1 r plus h plus 3/3 2r minus 1/2 99/100 ਦਾ ਸਕੇਅਰ 1/r। ਜਦੋਂ ਆਪਾਂ ਇਹਨੂੰ ਫਰਦਰ ਸੋਲਵ ਕਰਦੇ ਤਾਂ ਜੋ h ਦੀ ਵੈਲਿਊ ਆਊਗੀ ਉਹ ਆਪਣੇ ਕੋਲ ਕਿੰਨੀ ਆਊਗੀ 99.5 r। ਕਿੰਨੀ ਆਊਗੀ h ਦੀ ਵੈਲਿਊ ਆਪਣੇ ਕੋਲ 99.5 r। ਇਹ ਉਹ ਹਾਈਟ ਹੈ ਜਿੱਥੇ ਪ੍ਰੋਜੈਕਟਾਈਲ ਮੈਕਸਿਮਮ ਸਪੀਡ ਕੀ ਹੈ ਜਾ ਸਕਦਾ, ਤੇ h ਦੀ ਵੈਲਿਊ ਆਪਣੇ ਕੋਲ ਕਿੰਨੀ ਆ ਗਈ 99.5 ਆ। ਠੀਕ ਹੈ, ਇੰਨੀ ਹਾਈਟ ਤੇ ਪ੍ਰੋਜੈਕਟਾਈਲ ਕੀ ਆਪਣਾ ਜਾ ਸਕਦਾ, ਇਹ ਆਪਣਾ ਆਨਸਰ ਹੈ। ਓਕੇ, ਥੈਂਕ ਯੂ।